China has once again stunned the world with its latest achievement, an ultra-fast underground vacuum train that has shattered all previous speed records. This innovative marvel, a first of its kind, uses superconducting magnets and a low vacuum pipeline to achieve speeds once deemed impossible. China's cutting-edge maglev Hyperloop train has grabbed global attention by reaching a stunning speed of 387 miles per hour, 623 kilometers per hour, in a low vacuum tube, driven by superconducting magnets and advanced levitation technology. This ultra-fast train moves effortlessly through a near-vacuum environment, offering unparalleled speed, comfort, and energy efficiency. Picture traveling at speeds comparable to commercial jets while maintaining a minimal carbon footprint. This is the future we've been anticipating. Stick around to see how China's maglev train could revolutionize transportation as we know it. China is making major progress in transportation with its new ultra-fast underground vacuum train. This innovative development is transforming high-speed rail technology. The train uses magnetic levitation, maglev, to glide through low vacuum tubes at speeds that can reach up to 4,000 kilometers per hour. What's unique about this train? It floats and moves using magnetic forces, eliminating the need for wheels or brakes. This makes it lighter and more energy efficient. With advanced maglev technology, it can travel over 1,000 kilometers per hour, similar to an airplane. In contrast, current high-speed trains top out around 350 kilometers per hour. This new vacuum train surpasses that, offering much higher speeds and efficiency. The low vacuum environment reduces air resistance, allowing the train to achieve record-breaking speeds with minimal friction. It's a formidable competitor to air travel. China's Aerospace Science and Industry Corporation has achieved significant milestones with this train. They conducted successful tests in low vacuum tubes, breaking speed records and demonstrating stable levitation at high speeds. These successes highlight the potential of merging aerospace and rail technologies to build a super-fast national transport network. The advancements made paved the way for future improvements in high-speed rail, making this ultra-fast vacuum train a powerful alternative to traditional high-speed trains and even airplanes. China's Aerospace Science and Industry Corporation has made significant strides with this train. By combining advanced maglev technology with a low vacuum environment, China is setting a new benchmark in rapid transit, showing a future where national transport networks are faster and more efficient than ever. This ultra-fast maglev train could revolutionize global transportation and trade. If it's scaled up and implemented successfully, it could drastically reduce travel times and transform the movement of people and goods worldwide. Imagine traveling from New York to Los Angeles in under 2 hours, or from Beijing to Shanghai in just 45 minutes. Such speeds would make air travel seem slow, affecting business logistics and daily life. People could live farther from cities and still commute quickly, while businesses could broaden their reach and optimize their supply chains like never before. For international trade, moving goods at these high speeds would offer a significant advantage. Perishable items could be transported over long distances much more quickly, cutting down on waste and fostering new global partnerships. This could revolutionize global supply chains, enabling manufacturers to source materials from farther away while still delivering products swiftly. There are also environmental advantages to this development. Transitioning from fuel-consuming planes and vehicles to a maglev network could reduce carbon emissions, helping countries meet their climate targets. Some estimates suggest that replacing regional flights with ultra-high-speed trains could cut emissions by 3 to 4% in certain countries. In the long run, China's maglev train could transform global transportation over the next few decades. If it's expanded and incorporated into international networks, it could link the world in unprecedented ways. As the first to achieve speeds over 600 kilometers per hour, 373 miles per hour, in a low vacuum tube, China is now leading in this advanced technology. This achievement highlights China's technological prowess and its ability to push the limits of high-speed rail. By merging aerospace and rail technologies, China has set a new benchmark that could render traditional high-speed trains obsolete. This positions China as a global leader in transportation, with the potential to share its innovations and expertise around the world. China's ambitious maglev plans are quite impressive, constructing a 60 kilometers, 37 miles, test track capable of reaching speeds of 1,000 kilometers per hour, 621 miles per hour, would establish China as a major player in transportation. This would exceed the capabilities of high-speed rail systems in other countries, such as Japan's Shinkansen and Europe's TGV. This technological edge could offer China significant economic and geopolitical advantages. The country could become a key partner for nations looking to modernize their transport networks, using these collaborations to boost its global influence. Moreover, the enhanced speed and efficiency of moving goods could strengthen China's manufacturing and logistics sectors, reinforcing its role in global supply chains. China's development of an ultra-high-speed maglev train has drawn the attention of major global powers like the United States and the European Union. They are observing these advancements with both interest and concern. From the U.S. viewpoint, China's progress in maglev technology could challenge American leadership in transportation innovation. Trains operating at speeds over 600 kilometers per hour, 373 miles per hour, might give China a competitive advantage, potentially making U.S.-based air travel and shipping less appealing. There's also a national security aspect. The U.S. could view the integration of aerospace and rail technologies as having dual-use potential, possibly undermining American technological supremacy in aerospace and defense. Consequently, the U.S. may closely track China's advancements and seek ways to enhance its own transportation technology, potentially leading to increased investment in domestic high-speed rail projects and research to surpass China's maglev capabilities. For the European Union, China's advancements in maglev technology present both challenges and opportunities. The EU has its own ambitious high-speed rail projects, such as the proposed Hyperloop 1 system designed to link major cities. The prospect of China's maglev trains surpassing these initiatives could pose a threat to European technological leadership. However, the EU might also view this as an opportunity for collaboration. The sophisticated materials, engineering, and control systems required for these high-speed trains could open doors for European companies to participate in the development and deployment of the Chinese maglev system. This could result in technology transfers and joint ventures that benefit both parties. Ultimately, the reactions from the US and EU to China's maglev breakthrough will likely involve a mix of competition and collaboration. While there may be a drive to maintain technological superiority, there could also be efforts to capitalize on this new transportation innovation for economic and geopolitical gain. China's ultra-high-speed maglev train, operating a low-vacuum tube, represents a significant technological advancement. Although it differs from Elon Musk's Hyperloop concept, which aims to transport passengers and cargo through nearly complete vacuum tubes at speeds exceeding 1,200 kilometers per hour, 745 miles per hour. China's system uses a less extreme low-vacuum environment. This approach is more practical and allows for gradual implementation, addressing the engineering challenges of true vacuum systems. Despite this, the Hyperloop's potential for even higher speeds continues to capture public interest. As China makes strides with its advanced maglev technology, its ultra-fast underground vacuum train has already achieved several important milestones. In February 2024, the China Aerospace Science and Industry Corporation announced a major advancement. Their train exceeded its previous speed record of 623 kilometers per hour, 387 miles per hour, in a 2 kilometers low vacuum tube. While the exact new speed wasn't revealed, the test demonstrated stable levitation and successful integration of technologies. KSIC plans to expand the test track to 60 kilometers, 37 miles, and target speeds up to 1,000 kilometers per hour, 621 miles per hour, which is comparable to commercial air travel. If they succeed, they aim to connect key Chinese cities such as Beijing and Wuhan with this cutting-edge transportation system. Are you excited about the potential of ultra-fast maglev trains? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Explore endless tech possibilities for an exciting future.